All right, here's a little help with the lab. So this is part 2, which is a series within a parallel. Well, why I would call it that is because these two, resistor 2 and 3, are in series because there's only one path in between them. There's no junction there. In this series then, if you did kind of think of it as just one resistor, all right, cover these up to just make one resistor, it's then in parallel with R1. So these are in series within a parallel connection. When finding the total resistance, we have to simplify this picture. You could, of course, do it without the math, but for the sake of when I ask you to find current and voltage and you watch Abby's demo, I'm going to want you to actually include pictures as well. So how we would go about simplifying this is we actually try to find the 2 resistors, or 3 in some case, but I won't really give you that in this lab. 2 resistors that have either a series or parallel relationship with nothing else interfering. Well, we kind of already talked about that for this. These are in series with nothing else in between because there's only one path there. There's no junction that's messing up that relationship. So what I would then do is I would simplify these first. Mathematically, it's just a sum, so I could add those, of course. And I could kind of show that to the side. I could say, okay, the combination of resistor 2, 3 is going to just be the sum because they are in series. So if I gave you numbers, you could solve for that. And then what you would do is you would redraw the circuit, keeping resistor 1 still the same because we didn't do anything to resistor 1. But instead of drawing both resistor 2 and 3, I would draw them as a combination. All right, so sometimes you'll hear these called combo circuits. And really what that then says is the value that I got for the combination, that is represented right here as just one resistor. Okay, make sure you label things carefully, of course, so that you know that this is not an individual resistor but a combination. The next step you could then do is finish it off by combining the parallel. All right, so again, if I gave you numbers, you could then find the total resistance, or if you wanted to call it equivalent, you could, by basically doing the inverse equation since these are in parallel with one another. All right, what you would then want to do is, again, for the sake of WebAssign and even for the lab, because I want to see a final picture, is you would then draw one final picture that basically is representing the total resistance of the circuit. All right, so this is actually a combination of all 3 of these, 1, 2, and 3. All right, sorry, I was out of picture there. So that would be the final combination. All right, one total resistance, which is representative of all 3 resistors. Okay, this will be really essential for WebAssign, not so much in this lab, but for WebAssign when you get here, then we're gonna, of course, find things like current and voltages, okay?